Hi, I'm Griffin White, Managing Director of GWC GmbH. Today I'm going to be walking through a couple use cases with you of some software we've built in previous projects. Our first use case is in the finance sector, where I'll show you some automated trading software that we've built, as well next use case is in the public sector, in a public genomics laboratory here in Zurich, and then some software we have built for an AI startup. Okay, let's get started. Centara is a prop trading company which uses proprietary machine learning models to generate predictions of future market dynamics, including volatility and funding rates in perpetual futures markets. For Centara, we've built over 15 dashboards on a variety of infrastructure, including dedicated machines and cloud VMs. Some of the dedicated machines and running jobs you can visualize here in the dashboard. This front end was built using Next.js app router for the front end, on top of a backend microservice built in Python, fast API connected to a Postgres database via SQL Alchemy as an ORM. Here you can just see some test data for an interactive dashboard which we have built. So another dashboard we have built for Centara is built using a totally different stack. Also many microservices running in the background to manage this high throughput time series data. But this is an interactive dashboard using Python Dash, where you can easily interact with plots, download them as you like, and of course have some small amount of interaction in the tables and plots as well. We of course document everything we do. We built a time series library for this project, which can be seen here. I will also include a link in the application documents so you can take a look for yourself. This is an open source time series library for managing stateful time series and data tables in Python. The next set of applications I'm going to show you are from a project we've been doing with the ETH Zurich and University of Zurich at their joint research facility, Functional Genomics Center, where they manage their laboratory operations via bFabric, an in-house laboratory management software. For the ETH and the UZH, we have built a variety of satellite applications which authenticate directly against bFabric using standard JSON Web Token authentication. For instance, we can look at an RNA-seq application which processes large jobs on genomic data. Here we have a small interface where the scientists can trigger a job. In application documentation, for usability, you can see everything which is going on under the hood, any data which has been created with this application, as well as the queues running in the background. This is on the test system, so there are some failed jobs here. Okay, of course, again, everything we do is fully documented. This is the Python library we built for this project. This Python library is the backbone of over 12 satellite applications and counting for the Functional Genomics Center. It's also open source. You can check it out at your convenience. Another application is for a standard laboratory procedure, qPCR. We can visualize qPCR data. I will just upload a file to the interface, and it will display the qPCR data which has been processed by this instrument. I can filter samples, removing them here. I can correct samples individually by fragment length of the DNA strands. I can save these data and merge them with the data directly in bFabric and ultimately update bFabric. And the final application is for demultiplexing large genomic datasets in the Draugr UI. Here again, you have a small set of a small interface where the scientists can trigger these jobs, some in-app documentation, and of course for usability, a built-in bug report mechanism whereby users can submit a test bug report, which creates a ticket in our OTRS queue and directly sends me an email so that I know, hey, there's something to look into there. So this is just a nice to have usability feature, how we manage our quality with the Functional Genomics Center. Okay, the last application that I'm going to show you here is one we built for a small AI startup, Prism. Prism is an AI application which allows you to connect custom knowledge sources to a variety of large language models. You can upload files, scrape the internet recursively to contextualize communications with LLMs. Here we're logging in. You can see we're authenticating directly against Google. So this project was built using the Next.js app router, built on a fast API Python backend with SQL Alchemy ORM connected to a Postgres database and a Redis cache. We have also built a custom high-dimensional vector search algorithm using Meta's open source FACE, Facebook AI Similarity Search, as a starting point. So here you can easily schedule background jobs. I can create a new knowledge base, GWC GmbH. I can create this knowledge base. To this knowledge base I can add websites, and I can add directly our website to the interface. I can tell it to scrape recursively, meaning it will index all of the web pages connected to this base domain. I click add, and you will be alerted through the interface when these scheduled jobs are finished. So here you can see that we can easily schedule background jobs to scrape various web pages for information we'd like to feed our LLM. The background workers are also auto-scaling so that it can handle an indefinite amount of web traffic concurrently. Our cloud-native infrastructure helps us achieve this. We're alerted as knowledge is being indexed in the background, and I can probably already ask it a question about the data which we've fed it. Is GWC GmbH. And a variety of microservices are invoked here to grab the information that we have scraped using these jobs and feed it to an LLM. It even provides us with a link to our website here. So I would just like to close by saying thank you very much for your time and attention. I look forward to discussing any of these projects with you and more at your convenience. Goodbye.